So today we're going to be doing problem 29 on page 384, solving or proving trig identities. So the problem we're going to be proving is the tangent squared of theta equals 1 over the cosine squared of theta minus 1. So to do this, we're going to use the Pythagorean identity, tangent squared of theta plus 1 equals the secant squared of theta. Set that off to the side because we're going to need it. Okay. So to start, we want to make this half of our original equation look like this first half of our identity. So we're going to take the equation and add 1 to both sides. So then we get tangent squared of theta plus 1 equals 1 over the cosine squared of theta. So then we're going to use the identity secant of theta equals 1 over the cosine of theta. So we're going to look at the second half of our original equation, which is 1 over cosine squared of theta, and take both factors of that, which are 1 over cosine of theta times 1 over the cosine of theta. We're going to look at the secant squared of theta. We know both factors of the secant squared of theta are 1 over cosine of theta and 1 over cosine of theta, which means that 1 over the cosine squared of theta also equals secant squared of theta. So then we're going to add it back into our identity. So tangent squared of theta plus 1 equals the secant squared of theta. And we're going to take this identity and turn it back into our original equation by subtracting 1 from both sides. And we get tangent squared of theta equals secant squared of theta minus 1. But we know secant squared of theta equals 1 over the cosine squared of theta. So now we know that tangent squared of theta equals 1 over the cosine squared of theta minus 1.